we're going to build up to, we're getting closer to the examples of classes. Like you might get something that's like x minus 5, x plus 1, x plus 5. Now, one thing you should remember at multiplication is that multiplication is commutative, which means that order does not matter. Which two of these binomial pairs should you multiply if order does not matter?
The x minus 5 and x plus 5.
That's right. You should do those first. That's a special product. Your teacher kind of refers to them later on. It's just difference of squares. So like it would be nice if you recognized, and this will save you time on in your class. You know, this is a minus b, a plus b, which always becomes a squared minus b squared. So in your problem, it would become
X
x
squared
squared minus,
minus 25.
and then you have x plus 1. Go ahead and FOIL this for us, please.
I got x cubed plus x squared minus 25x minus 25.
Like this?
Yeah.
All right, that looks good. And you even did it in a standard form, which is even better. Standard form is descending. The exponents descend. Okay, but this doesn't always happen, right? Sometimes you get things that just don't, they don't match up. So the order doesn't matter. So it's your choice. So I'll FOIL this. This ends up being x squared plus x minus 12. Okay. And then from here, there's two ways of looking at it. It's either, and let me actually, and both are correct. There's not like a right and a wrong. Let me actually just move this off to the side a little more. There's two ways to look at this line here. If I could just get another copy. So you either see it as x squared multiplies each of these, x multiplies each of these, and then minus 12 multiplies each of these. Or you see it as x multiplies each of these, and minus 2 multiplies each of these. My preference is actually the one on the right. I like taking the fewer number of ones into each of these, but there's no right or wrong. Do you see it one way or the other? Doesn't matter which way, but do you see it one way or the other in terms of how to do this?
Usually the first one where it's x squared times x and then, or wouldn't it? Yeah, x squared do that. Yeah, x
Okay,
squared.
yeah, that's fine. So this is how most students write it, which I do not like. They write it in a line here, which I'm going to show you a better way in a moment here. Now this one just so happened to work out that all the like terms are right next to each other. Doesn't usually happen. Okay. Any questions on that?
No, I get it.
Okay, so let me give you one to try here. Yeah, if you try and the exponents can change. Like it can be an x cubed minus 4x plus 1 times x squared minus 2. So I want you to take each of the ones on the left here, multiply them in. Kind of a rainbow here. Go ahead and work that out, please, as best you can.
All right, I got x, uh, x to 6 minus 6x cubed plus x squared minus 8x minus 2.
Everything is correct except that exponent. When you multiply, when the bases are the same, you add the exponent.
So it'd be x to the fifth.
Yes, very good. Very, very good. Okay. All right. So the other type of problem you'll see here, and this is something your instructor will probably do, is they'll probably make it where they put they throw in some awkwardness like this, 4 minus 2x plus x cubed like this. So the point is of I guess a problem like this is that the negatives always go with the one to the right. All right. So what I don't think is a good idea is to reorder it. I think you should just deal with it as is and reorder it later. All right. So why don't you try that one more before we move on to something else?
I got 2x cubed minus 2x squared minus 2x plus 4.
So we're missing some powers here. Like the last one should be minus x to the fifth. Like that has to be in there. So let me write this out here. Let me see. So you did really well on the last one. I'm surprised this one didn't get my right. So 1 time each of those on the right is 4. I'm sorry. Well, let me make sure. Did you do 1 times each of these, or did you do 4 times each of these?
1 times each.
Okay. So 4 minus 2x plus x cubed. So now minus x squared times 4 is minus 4x squared. Minus x squared times minus 2x is plus 2x cubed. Minus x squared times x cubed is minus x to the fifth.
I think I missed that last part, but that's
Okay.
fine.
All right. So that's why some students like draw the rainbow to make sure they get them all. You can also count, right? You should have 6, you should have 6 when you're done. 2 of these times 3 of these should be just 6 terms. Now they combine, but so this becomes minus x to the fifth. And then like terms here, plus 3x cubed, maybe cross them out as you go. Minus 4x squared, minus 2x plus 4, like that. Any questions, thoughts on that before we proceed?
Um, no, I think I get it now. Yeah.
Okay. So there's a bunch of special products. Your teacher calls them special product patterns. Yeah, just step that in. So there's a bunch of these, and we've already talked about the first one. The first one is difference of squares. That's the a minus b times a plus b equals a squared minus b squared. So the trivial examples are ones that, do some examples here. It's like x minus 1, x plus 1 becomes x squared minus 1. Is that okay? Clear how
Yeah,
we got that? Now, let me give you one here. X minus 3, x plus 3. What does that become?
x squared minus 9.
Yes. Okay. You're squaring the first, you're squaring the second. Now, what if the order's flipped? What if it's 4 minus x, 4 plus x? Does
Would
it
it
still
be,
apply?
so it would be 16 minus x squared?
Yes, 16 minus x squared. All right, good job. Good job on that. All right. Now your teacher could be deceptive though, and they could do something like this: x plus 1 minus 1 plus x. Okay. Is that difference of squares? Well, it doesn't look like it. But if you rearrange it and you go x minus 1 on the right, x plus 1 on the left, all of a sudden it is.
Yeah,
So your teacher will probably do something like that. Okay. Now, the more difficult ones are when you get something like 2x minus 5, 2x plus 5. In this case, the A is 2x and the B is 5. So you're squaring the 2x, you're squaring the 5. What does this become?
that would be 4x squared minus 25.
Really good. Okay, let me give you a couple more here. Say it's a 3x minus 2y, 3x plus 2y. What would that become?
9x squared minus 4y squared.
Very good. Okay. Give me just 30 seconds, please. I'll be right back with you. All right. Good job on that. Um, right. So the other special products here are given. Actually, why don't I do this? Why don't you try some of these examples and practice? I do need to step away. I apologize. I'm just gonna need like less than 5 minutes, and I'll extend the lesson for sure. Why don't you try some of these, and I'll be right back with you. All right, Karthik, I'm back. Any questions on anything that was here before we move to the other
Uh,
special products?
no.
So I'm interested in if you did the P6. Did you happen to do that one?
Yeah, yeah.
Okay, so here is the answer. It's x to the sixth minus 64.
Yeah, I got that.
Okay, good, good, good. Okay. Now, the other special products you've actually seen before. I mean, I've written them down. Your teacher probably wrote them down, but they're going the other direction. So if you get something in the form of a plus b squared, it's always a squared, okay, plus b squared. But it's like, what goes in the middle? Well, you multiply these together, a times b, and then you double it,
Yeah,
okay? And then similarly, for this one, you square a, you square b. But then when you multiply them together and double it, it's negative because of this negative here. So they're actually the same formula, just with swapping signs. So the idea is that you can more quickly multiply something like x plus 7 squared. It's x squared plus 49. And then 7 times x is 7x doubled is 14x. By the way, these are all called perfect square trinomials. You might remember that from previous
yeah.
unit. So the mistake here, here's what happens. The mistake is that you forget about this and then you just write x squared plus 49, which is completely wrong. It has to have three terms. There's a rule here which says that this exponent tells you the number of terms because you add one to it and you always get one more than the exponent. You'll see that later on. Let's say it's something like a 2x minus 3 squared. So this is now 2x squared plus 9. Then you take the 2x times the 3, that's 6x, and then you double it to get 12x, but it's actually negative here. It's negative 12x. You do have to square that first one. And again, it's another perfect square trinomial. So you want to try really, really hard to use these formulas. They're going to save you a ton of time. Same with the difference of squares that we were doing earlier. These are going to save you a lot of time. Because what your teacher's going to do is give you some problems like this, which will kind of combine what we've been doing. It'll be like x plus 4 squared times x minus 2, x plus 2. This is like a, kind of a quiz question. So could you tell me what this is when you expand it? And please look at that special product pattern to do it. You need to scroll up for those formulas or do you have them in front of you?
I remember them from the top. Yeah.
Okay. Are you doing the whole thing?
Yeah, I
Okay.
simplified the x
All right.
plus
Yeah,
4 squared.
yeah, okay. I always forget you do like to do that. That's, you're a good student. Um, All right, how are you doing on this one?
Um, I'm done with simplifying down. So I got x to the fourth plus 8x cubed plus 12x squared minus 32x minus 64.
Really good. Really, 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 really good. Okay. And your teacher will probably disguise some of these things, like she'll throw in like an x cubed minus 8 times x squared minus or plus 8, and hoping you'll not really you hoping you'll think, oh, this is difference of squares or something, right? Like he's going to be deceptive with these, and you have to be on the lookout for how to do them. But that special products are really important. They'll save you a ton of time here. Any questions on those special products before we proceed to Pascal's triangle?
No.
Okay. All right. So the the Pascal's triangle, maybe you've seen this before. You'd start with one and one, one and one. This is a Pascal. He did a lot of stuff, more than just a triangle, but it's probably the first thing you will use it for. So the rule is that there's always ones down the I guess I call them the diagonals, but I don't know, they're the sides. And then when you get to this is row 0, this is row 1. That's a little bit awkward as well, but about row 0 and row 1. When you get to row 2, you have to start adding. So the 2 comes from these two up here. And then you've got 3 and 3 that comes from these. And then the ones still go down the sides. So this is row 3. Okay. And then you get 4, 6, 4, 1, and 1 like that. You see the pattern. You see how I'm
Yeah.
getting these numbers. So what you don't do is you don't memorize this. You build it. You build it once for the test, and then you shouldn't have to go much past this, although you could. Um, you may also go out to the internet and find a wonderful Pascal's triangle that way. See if there's a nice image on that. Um, I like kind of just the numbers floating. I don't really like the ones where they have like rectangles and boxes around them. So like here's one you might see. But the key, and this is something I always have to remind myself, is that that's row 0. It's row 0, not row 1, row 0. That'll be important here in a moment. Okay, so the way that you use Pascal's triangle in this part of the course is your teacher's going to give you something awful like x plus 2 to the power of 5. And most teachers make the point that what you don't want to do is you don't want to do this, even though you might be tempted to, right? That gets old pretty quickly. Okay. So there is a way to do it faster that we're going to go through here for the rest of our lesson today. And the way to go faster is to know the formula. So the formula is the following. You consider this first term, I'm going to think of it like an A and think of the second one with the sign like a B. So what you do is you start out by taking A to the power of 5, B to the power of 5 minus 5. This will make more sense in a moment. Then it's A to the power of 4, B to the power of 5 minus 4, A cubed, B to the power of 5 minus 3, and then so on, okay? So we're going to actually do that for this problem here. I'm going to just rewrite it here. x plus 2 to the power of 5. So the way this works is your a is x, so it's x to the power of 5, 2 to the power of 0. X to the power of 4, 2 to the power of 1. X to the power of 3, 2 to the power of 2. X to the power of 2, 2 to the power of 1. Sorry, 3. Going the wrong direction. X to the power of 1, 2 to the power of 4. X to the power of 0, 2 to the power of 5, like that. What do you notice about the sum of the exponents each time? What do they always add up to? Are you still with me? Maybe you're muted. It doesn't look like you're muted though. Can you hear me?
Oh, that it adds up to 5.
Yes. Yes, yes, yes. Okay. And that's really important. The exponents always add up to 5. Okay. And you can see that these go down, these other ones go up. Okay. And then you may be wondering, well, why do we do this thing with Pascal's triangle? Well, the exponent tells you the row. So row 0, row 1, row 2, row 3, row 4, and row 5. Now, how many coefficients do you see in this row here? How many numbers do you see in this row?
That's 6.
And guess what? They go with these 6 here. 1, 5, 10, 10, 5, and 1, like that. All right, so we're going to keep going here. So this first one becomes 1x to the 5th. So as a reminder, anything to the 0 power is 1. The next one here is 2 to the power of 1 times 5. That's 10x to the 4th. This next one here is 2 to the power of 2, which is 4 times 10 is 40x cubed. 2 to the 8, 2 to the third is 8 times 10 is 80, 80x squared. 2 to the 4th is 16 times 5 is 80, 80x. Anything to 0 power down here is 1. 2 to the 5th is 32 times 1 is 32. So there is your answer when you combine it all. X plus 2 to the power of 5 is 1x to the 5th plus 10x to the 4th plus 40x cubed plus 80x squared plus 80x plus 32. Notice no multiplication was needed. So we're going to look at another one, but is that okay so far?
Yeah.
So the thing I want you to take away is this pattern with the exponents, and then this whole thing with the row. We're going to do that again. We got to multiply, and then we combine them all. So let's do another one here. Let's do something a little bit easier. Let's go x minus 3 to the 4th. All right. So I tend to work vertically on these problems. I think in the classroom they go horizontal, which I don't understand. It seems like it's more of a table thing, but it's x to the 4th minus 3 to the 0. So notice that that negative goes with the 3, and these have to add up to 4. Then it's x to the power of 3 minus 3 to the power of 1, x to the power of 2 minus 3 to the power of 2, x to the power of 1 minus 3 to the power of 3, x to the power of 0 minus 3 to the power of 4. Is that okay so far?
Yeah.
Now they all need a coefficient. So that's where you go and build your Pascal's triangle if you don't have it in the classroom. So this is row 0, row 1, row 2. So we need 5 coefficients. 5 coefficients. So we got to keep going here. 4, 6, 4. So now we've got it. Row 4. See how this tells you row 4?
Yeah.
So those are the coefficients here. Whoa, sorry about that. So we have 1, 4, 6, 4, 1. And now you multiply these together. So anything to the 0 power, first one, anything to 0 power is 1. So the first one's just x to the fourth. It's not always just the x to the power, but it could be. The next one is -3 times 4. That's -12x cubed. 6 times, this is 9. So that's 54x squared. -3 cubed is -27 times 4 is -108. And then -3 to the power 4 is 81. Any questions on how we combine those? Okay, so I'm gonna have you try one now. Not gonna make it super difficult, but I'm gonna have you try one here, less difficult than these. I recommend doing it this way and the whole table thing. Let me know if you need to get this down on your paper or anything like that before I have you try one.
I have it done now.
All right, so let's have you try x minus 5 to the power of 3. If you need me to scroll up, I absolutely can do that.
All right, I got x cubed minus 15x squared minus 15x minus 125.
Like that?
Yeah.
Okay, let me double check here. You're missing, this one is off. This one is off here. The other thing is that it always alternates sign, which I didn't say from the previous one. I thought maybe you might notice positive, negative, positive, negative, positive. If it switches sign, it always alternates. So take another look at this one. That's the x times -5 squared. And then the coefficient in front of that is probably a 3.
Yeah. Yeah,
So
X
you have
one
to
is
square first. So what should this change to?
positive 25.
Times 3.
Positive 29 times 3, which would be 75.
All right. So on my website, there is, and you can get this anywhere, but there's a like a recommended exponent table. Let me see if I can grab a quick snip of that, because you really do need to know some of these exponents pretty quickly. So I kind of feel like all of these are reasonable. Your teacher may disagree. Like I think you need to know 2 all the way up to like the power of 12, 3 all the way up to the power of 6, and so on here. Like any of these are fair game to learn. Um, you might argue some of them right on the edge, but that's kind of up to you. So let's do one more here. We'll do another one together here. Let's do a 2x minus 1 to the power of 7. Okay, we'll do this together. So this gets pretty nasty. Okay. Um, it's 2x to the power of 7, -1 to the power of 0. 2x to the 6th, -1 to the 1. Now, what I like to do is I actually like to keep going down the list. It's easier to do the same thing over and over again rather than to be switching back and forth. And you already saw me made a mistake earlier where I went the wrong direction with the count. So this one is -1, and I'm going up this time. So I would recommend doing that. And then we need all the coefficients here, which boy, there's a lot of them. Um, I'm just gonna grab the table. You probably want to make the table on like the backside or the top or somewhere. And like I doubt your teacher will give it to you. You should. I mean, just it's like you just have to prove that you know how to find it. But we're going to row 7. So 0, 1, 2, 3, 4, 5, 6, 7. And we need those coefficients there. And when you write them out, hopefully they all like that you have the right number of coefficients there. Is that okay so far?
Yeah.
All right. So this is where it's like, 2 to the 7th, what is that? And that's where it's really helpful to know this. It's 128. This is 128, x to the 7th. 2 to the 6th is 64. 64 times 7. I mean, that's not unreasonable. It's a lot of work, though. It's 420 plus 28. It's 438, x to the 6th. But now you got to deal with this negative. So there's the negative. 2 to the 5th is 32. 32 times 21. Yeah, we can figure that out later if you want. Some of them get really bad. Like this one's 16 to the 4th is 16. 16 times 25. 16 times 35. X to the 4th, but this one's negative. And then this is 8. 8 times 35. That's more doable. That's 270 x cubed. Q squared is 4. 4 times 21 is 84, but it's negative. And then this is 2 times 7, which is 14. So it's totally doable. You might get some 2-digit by 2-digit multiplication. You'll be okay. All right. So there's actually a little bit